So welcome back. If you would like to take a seat, we'll go on to our next session. And we're going to be talking about protein and canola protein and all the opportunities there. And we've got a really great slate of speakers to address this topic. And then we're going to have a open panel session where we can ask them all kinds of questions. So while we're listening to the presenters, please make notes of some questions you'd like to talk about and discuss with the group. First up on the agenda is Lisa Campbell from Protein Industries Canada, or PIC. And so she's going to talk about PIC canola projects overview and give us some idea about future opportunities. She's the Director of Programs at Protein Industries Canada, where she works with PIC members to develop programming and project proposals, provides program guidance, and manages and evaluates ongoing projects. So Lisa, there you are. I'll turn it over to you.
So how do I go forward and backward?
I think it's just the big green button.
He's presenting on Zoom at my desk. Hi, everybody. Thanks for the intro, Rex. It's great to be back. Many years with the Canola Council, many years coming to this meeting. It's great to be back in person. So I'll take us a little of a bunny trail today down canola protein innovation, in particular protein for the plant protein market rather than more of a commodity market. It's not the big green button, Rex. Oh, now it is. Okay, here we are. Who is Protein Industries Canada? We are a newer company. We were formed about 4 years ago. We are one of Canada's 5 global innovation clusters. Our mandate is for Canadian field crops to work into the plant protein industry. So we've had over the 5 years that we are funded, we have about 160 million to invest in projects. So right to now, we've gotten to 310 million investment with our partners. We look for 3 major things when we talk about our projects. One is incrementality. So the work these companies do has to be in addition to what they would normally do as part of their business operations. We look for collaboration. So all the companies that we are funding have to apply to us with a partner, at least one partner, and innovation and path to commercialization. Any project that comes to us, we can invest like along the TRL timeline from not quite discovery, but lower along right through to commercialization. But every project we fund has to have a path to commercialization. So this is where we're going to be. So this is the anticipated output by the end of the value chain. So 660 new products and services, 10,000 direct and indirect jobs. Our total project value right now is 485 million. That includes the investment from the companies. And the GDP impact over 10 years is estimated to be 15 billion. So our mandate, we invest across 4 areas: create, grow, make, and sell, with the share among those pillars being approximately 20-20, 40-20. So create is what we've talked a lot about already today. It's that breeding work to improve quality, things like increase in protein, decrease in fiber. We're using crops like peas and canola and fava in ways that they haven't been used before. So the breeding has to catch up to get the companies what they need. In the grow pillar, that's again a lot of what we've talked about today in precision agriculture. It's digital support systems, it's agronomic improvements, it's those types of factors that lead to the quality. Also very important in the plant protein industry, that chain of custody traceability. So most of our companies, they're going into end product markets that demand different things than a commodity market might. So when we look in the grow pillar, we're looking at things like traceability in terms of allergenicity. So in oats, that might be gluten-free oats. In peas, it might be making sure that it hasn't been grown on fields with soybean on a previous years. Also things like sustainability markers, non-GM, a whole bunch of different areas that the end markets in plant protein demand that we are getting set up here in Canada. Make is really what it sounds like. It's a lot of the ingredient processing. It's new processing technologies, new processing plants, and it's also co-product and waste stream valorization. When you fractionate canola or you fractionate peas, you're going to get a lot of byproducts. So important to make sure those are used properly and waste reduction. And sell, again, what it sounds like, novel food and feed ingredients. That could be products that you see on your grocery shelf, can also be products that you're seeing in food service or in restaurants that you go to. The plant protein ecosystem is new in Canada. So in addition to our technology investments, we've also had to make some capacity building investments. So one of the major differences between our program and many others is by the way the global innovation clusters are set up, the concentration, the focus is on small and medium-sized businesses. So all of our projects have to have at least one Canadian-based small business in it. So we can fund multinationals, and we do. Well, you'll see a lot of them when I work through the projects, but we're setting up the ecosystem for all the companies, but in particular to tackle the issues that we see coming up and again. So when you're talking small business, what are the major issues to growth? First of all, access to capital. Very, very expensive for small businesses to scale up, especially those of our members that are building plants. Labor, skills, access to talent. If you build it, you need to have people to work in it. Regulatory modernization. The plant protein industry is quite new. There's regulatory impediments to putting products on the market here in Canada and in other countries. Intellectual property literacy, very important for SMEs as they develop their innovation, they have to protect it. So patenting, trade secret, working down that pathway, a lot of area for education and support. Also in infrastructure, we have great research infrastructure in Canada. It needs to grow for our plant protein processors. So it's things like the food centers, it's things like a pilot plant so they can move from a bench scale to a pilot to a commercial. It's also things like co-manufacturing, co-packaging. For many of our small clients, they have great products, but it doesn't make sense for them to build their own plant. If they have access to timely and high quality co-manufacturing, they can get to market faster. So when projects come into us, the main difference is that they are industry led. So in order for a project to go through our framework, it has to be applied to by a private company. So they have to come into us led by a company, and they have to have at least one other partner. Our smallest projects have only 2 partners. Most of ours have 3 or more, up to maybe 6 or 7. So those partners are all reimbursed directly from us through our program rate. Now, most of our projects, and I actually can't think of one that doesn't have at least one university collaborator. Usually they have food centers, contract research organizations, producer groups. All those groups can be part of our projects. They're just as subcontractors directly to the companies rather than to us. So most of our projects have 7, 8, 9, 10 different organizations working on them. So why Canada for plant protein when we have an established commodity market? Most of the same factors that make Canada a successful commodity market also make it a great player in the plant protein industry. So it's the agricultural land, it's the strength in crop production. We have great sustainable production here. We have high food safety and quality systems in Canada that garner a lot of respect worldwide. We have significant research capabilities, and we have the existing agri-food clusters in Canada that are supporting our members as they grow. And also we have excellent market access through to the US, Mexico, also through to Asia and the EU. So why canola? Because canola, we know it has an established oil market, it has an established meal market. There's canola, there's places for canola to go. So why does the plant protein industry, why did their eyes turn to canola? And that's for a number of reasons. And the very first reason is because there's lots of it. There's not a shortage of canola. There's plenty of canola to supply the industry as it exists today. The second reason is functionality. That next generation of plant-based food products, consumers have really strong ideas of how they want them to taste, how they want them to look, and the nutrition that they want. And canola offers a different amino acid profile. It offers different functionality. It offers our processors one more way to get a really fantastic endpoint. And finally, the same thing that makes canola a great livestock ingredient also makes it a great people ingredient. On its own, canola has a really good amino acid profile. It's got a very high PD-Cas, which is a measure we use in human nutrition for protein digestibility and value. So all those factors together make canola an ingredient that a lot of companies are interested in. So I'm going to take a quick walk through our existing projects that do deal with canola. So this is a fantastic bubble chart here with some bubbles representing the overall size of the projects, and that's including the company investment. So if I looked across, I did a quick calculation on our project portfolio, and about 43% of the funds we have invested right now in the technology projects are assigned to peas, specifically to peas. And that's not a really great surprise if you're driving across the prairies and you see all the pea protein facilities just popping up out of the ground there. So that's not a huge surprise. Behind peas is canola. So we're about 23% invested in canola in several larger projects that I'll talk about. And then following it up there, next is fava. So fava is the new up and coming kid on the block. It's got a lot of great reasons why people are interested in it. We're about 7% invested in fava. And then next at about 4% each is oats, chickpeas, and lentils. And then we got a smattering in there of some hemp, some soy, and a little bit of lupin for good measure. So we're based in Western Canada, but our projects stretch right across and everywhere from Vancouver to we right now have one all the way across into Eastern Canada. Our mandate is Canadian field crops. So that's, like I said, that's mostly prairie crops, but it is crops across Canada. So I'll chat a little bit about our different projects right now. Here, these three here are our three very first announced projects. So they had the longest runway of any of our projects. Our very first announced project and our guinea pig through our application process, thank you, Dave, is Botaneco. So Botaneco is an Alberta-based startup that is looking at novel oilseed-derived ingredients of canola, hemp, and sunflower. And that's all I'm going to say about Botaneco because Dave's chatting today. Our second announced project is Corteva. And Corteva is actually our largest project investment-wise, and it's looking at a hybrid canola seed with increased protein content and less fiber, looking at something more similar to soybean. So when companies come in for partnerships in our program, they often look along the value chain. So for Corteva, the partners in this project are Bunge, because they wanted to see how this new canola meal actually performed in our standard canola processing equipment that we have here in Canada. They also partnered with Botaneco because they also wanted to see how it might work in Botaneco's unique process as they go towards their more value-added canola protein endpoints. And finally here, Merit Foods. If you happen to be driving through the north part of Winnipeg in through Centerport, you might notice a brand new shiny white canola plant there, and that is Merit Foods. They are fractionating pea and canola protein. They're first to the market in canola protein. They now have full regulatory approval in Canada. They've been having a lot of buzz on their product. The way that they process canola protein, it's very soluble. It's light in color. I've tried it in a smoothie. I've tried it in a cookie. It's pretty fantastic. So they're getting a lot of traction on that. They also have a blended canola and pea protein. Canola and pea is complementary. So when they blend this protein, they end up with a PD-Cas of 1, which is equivalent in value to an animal protein. So that's really appealing to a lot of companies. So Merit's project here came in, and this was another full value chain project. They partnered, first of all, with Patura Seeds. Patura Seeds, small company outside of Winnipeg. And Patura is responsible for working with the farmer to get the products that Merit needs. So eye pre-preservation of non-GM canola, allergen-free peas, all of that sort of thing, as well as enhanced cleaning processes to get the seed the way that Merit needs it to enter their plants. So Patura was adapting the classic commodity process to meet Merit's needs. And then on the other end was the winning combination, more of a sports nutrition type supplement company. We're testing out how Merit's new proteins out of their plant worked in their finished products. We've quite a few digital projects, again, looking at that whole traceability and agronomic improvements. So provision analytics is one of them. Canola is an aspect of their work along with other more general crop improvements. On this one, precision AI, there's a lot of restrictions, there's a lot of asks from plant protein and companies, the companies that are formulating products. And precision AI's goal here is using a specific way of spraying to reduce herbicide use, which is appealing to most of our members that are supplying a lot of these end products and industries that are demanding really specific marketing. On this one, an initial project from Farmers Edge. They have 2 projects in with us. Again, it is on-farm precision agriculture, looking at blockchain, traceability, and increasing efficiency. This is a smaller project, the far right here. It is EMN and Infinite. And EMN and Infinite are 2 different companies that have Infinite's now called Grupo. EMN and Infinite both have very high value whey protein lines. And EMN is a medical food company. They have a whey-based tube feed. They also have a whey-based recovery product used in orthopedic surgeries. And Grupo is high-end sports nutrition company, so targeted sports supplements, recovery foods, things like that. Both of them are looking at how to have a complete plant-based line along with their whey-based line, and they're partnered with Merit Foods on their canola and pea, and also McMaster University, where they're doing all the clinical work to establish the efficacy of their products. Farmers Edge, and their follow-up project, they brought in a company called Truspix. Truspix is most well known in Canada for applying the chain of custody to beef cattle in Canada for McDonald's, and they're applying that knowledge from that industry, trying to carry it over to the plant protein industry to establish that same effect. New School Foods, this is a smaller project here. This is another interesting one. And so most of the meat alternatives you see on the product market today are more like ground products. You see beef burgers, you see the ground beef, you see chicken nuggets, you see meatballs. What New School Foods is looking at is an entirely new technology to get an actual whole muscle. What they're working on is a salmon fillet that looks exactly like a salmon fillet. They are using canola protein in there. I haven't tried this one, but the pictures look very, very, very cool. Also on this tab, Merit's follow-up projects. So in this one, they partnered with several of their end users to see how their first project was getting their plant up and running. Second was seeing how their optimized plant proteins worked in things like sports supplements, meat alternatives, and then Daya Foods, which is dairy alternatives. Smaller project led by a company called Wamame Foods. They're looking at, again, partnering with Merit Foods for that canola pea blend. Very specific, non-soy alternatives to the thin sliced pork and beef that you see a lot in parts of Asia. So this product, again, I haven't tried it. The pictures look fantastic. That is slowly coming to market. It's going to be marketed across Western US, Western Canada, far west of Canada, and into Asia. This is our most recently announced project, so we didn't have any more information on it, and this is just about as well as I can take a picture and make a slide without our comms team stepping in, so I apologize for that. So that shiny, glistening piece of tuna you see in that picture is not tuna. It is canola and pea protein. So Conscious Foods, if you are a plant-based food consumer and you've gone in your frozen and refrigerated aisle, you know the names Eves and Gardein. This Conscious Foods is the owner of Eves and Gardein's newest venture, and they're looking at having a raw type seafood product for a variety of different endpoints. They use seaweed for flavor. I I've tried this. I think they really nailed it. I think it's really intriguing. We can't buy it here in Western Canada. If you are in Vancouver, drop into Whole Foods and you can pick this up. So where do we go from here? We've just about wrapped up, like everybody else, we're wrapping up our framework. We finish up March 31st, 2023. Our path forward, we call the road to 25 billion. So 10% of the global plant-based food market is what we in Canada, we hope to capture for a total investment of total GDP of 25 billion. Now, where do we get there with canola? I think we're going to see some follow-on investment of the companies we're currently supporting. I think we'll see some new ones come in. I know that a few of the other panel members are going to be talking about their investments today. We will be opening up a new program. We're waiting on timelines right now from the government, but hoping that we will be some point early in the new year setting up a new call for EOIs. So look for that. So thank you. I'll look forward to taking your questions in the panel. I'll be here all afternoon as well.
Thank you very much, Lisa. And PIC is doing some fantastic work and really important to help us advance this industry. Now I'm going to have Rob Gulden come talk to us from the University of Manitoba. He's going to talk to us about factors contributing to seed quality in canola. And so he's a professor at the U of M, focusing on crop and weed management, and his research focus includes crop weed competition, volunteer canola management, crop and weed characteristics, and the effects of management on weed communities, plant spatial arrangement, DNA in the environment, and biostatistics. So that sounds like a lot. Have fun.
I like the way you snuck volunteer canola in there, because I usually don't get invited for talking about that topic. All right. Well, thank you for that introduction. Thank you for the invite. That time here is going to freak me out. And I'll get started with this talk. And it's part of, actually, it's nice to speak right after Lisa, because it's part of the Corteva bubble that we're talking about. And the project I'm going to review here is some modeling we're doing in trying to understand seed quality in canola. And it's funded by Protein Industries Canada. It's collaboration between us at the University of Manitoba. My technician, Jonathan Rossett, has done most of the modeling work. And then we have Corteva on board, who supplied a lot of the data, as well as the Canadian Grain Commission. And they've supplied some of their farmer data and measurements as well. So what are we talking about here? We're trying to understand and I had to draw this graphic for myself to get a feel for what we're talking about. Here we've got a canola seed or a circle that's roughly in the proportions of the seed constituents of canola, with oil, protein, and others in there. And I've drawn the degree of variation that we're after and that we're trying to understand in those question marks. And that's the portion of protein, that proportion of protein that changes, as well as the proportion of oil. The graphs on the right-hand side are the oil and protein content averages that we get from the Grain Commission. And you can see they go up and down, but they are quite closely related. So oil goes down, protein goes up, and vice versa. And we're quite aware of that. So here's the data set that we started with, and this was from the Canadian Grain Commission. I think we have a very good representation of the canola growing areas of Western Canada. And this, I forget how many data points were in this data set, 10,000 or more. And we took a quick look at that. It includes the years 2009 to 2017. I believe the numbers are pretty small. Hopefully you can see them at the back. But we looked at average protein across the prairie provinces, 14% to 28%, basically in all the provinces over those years. The means hovering around 19 to 23%, and that's sort of that's what we're chasing after. When we throw that into a statistical model, we don't really see a lot. Well, the only thing that we do gather from this is that we don't have a lot of explanatory variables, and therefore we can't explain a lot. And so we have a large proportion of the variation tied up in the residuals. So about 70% of the variation isn't explained. And so we went to Corteva to look at their data set and see what we can glean from it. What are we trying to do, or what are we trying to understand here? We're trying to understand this genetics by environment, perhaps interaction, but as an agronomist, I'm just very interested in the contributions of all these effects. And in this case, we've split environment into weather and management, or weather and soil factors and management. And that's, as far as the plant's concerned, environment is environment. But the management side, we have some control over. The weather and the soil, perhaps a little bit less. Not entirely true, and that's why all the bubbles intersect. And then we also, of course, have the genetic side of things, which are days to flower, maturity, pod fill, et cetera, et cetera, et cetera. So moving on then, we have this small plot data set, covers 4 years from 2017 to 2020. And in the final model, when we used about 16,000 data points, which is quite a bit. I'm not sure where small data ends and big data begins, but this is probably somewhere in there. I've color-coded the locations based on relative protein levels for each year, and you can already see from those, if that's visible at the back, you can see that we tend to have higher protein levels in around Saskatchewan, Saskatoon region. Those are the darker blips, or the darker markers. And the lighter markers are lower protein, and that tends to hover around Alberta. That's not all bad, because usually low protein means high oil. And then Manitoba hovers around the middle with a lot of medium levels of protein. We've got 65 environments in this study, which is quite nice. Usually you don't get that many environments, and it's a real bonus for the university to be able to work on a large data set like that, because typically in an academic setting, we don't have data sets that large most of the time. And there are a lot of different genotypes in this study. So 427 different genotypes. Some of them are recombinant lines, others are commercially released lines within the Corteva genetics or gene pool. Now, a little bit about the regression variables. I do need to talk about those a little bit to explain how many we calculated, and hopefully that'll help people understand the outcome of this regression analysis. We modeled protein, defatted protein, to delink it from oil content as a percent, defatted protein as a percent, and yield all at the same time. We can do that with partial least squares regression. So we've got the ranges of the values there too that went into the analysis. So the defatted protein ranged from 35.5% to 59 or almost 60%. And the ranges for the other values as well. So we're dealing with a relatively broad range. The genotype effects that we have are sort of typical things we take, data we collect in breeding type trials or variety evaluation trials, and that's days to flower, days to pod fill, days to maturity, plant height, and of course, genotype or cultivar. And all of those went into the model. Then it gets a little fuzzy. And that is the weather. We calculated a lot of different weather variables. Some of them, the first one is a range in days to minimum, or days of minimum temperature, and days of maximum temperatures within these specific ranges. So the total number of days that were between 5 and 8 degrees, minimums 8 and 12 degrees, minimums 12 and 15 degrees minimum, et cetera, et cetera. We also ran the actual temperature averages and running averages in 1, 2, and 3 week intervals, starting at maturity. We worked our way back from maturity with this, and calculated this for each genotype where we had, or they would have been the same for any of the genetics that matured at the same time, but they were calculated individually for the genetics within that experiment. Then we also had running averages of diurnal temperature ranges, et cetera. We had those diurnal temperature ranges also as a categorical variable, and we had precipitation in there, solar irradiation, and calculated a water deficit. So all in all, when we're done with all the weather variables, there are 352 weather variables we calculated, and then, of course, used the model to tease out the most important ones. Soil predictors, we had standard soil data. Now these ones were just a single value per environment. And again, it's excellent to have 65 different environments, because we are dealing here with a large enough data set, even when we only have one value per environment. And that's your standard soil characteristics. And then we have the agronomy side of things, where we had seeding dates, the amount of fertilizer applied. And the nitrogen fertilizer applied here, in this case, we have what was applied. We do not have soil residual nitrogen at this point in the model. If we can get all that data, we will stick it in. But keep that in mind, because nitrogen shows up as an important variable in the slide or two. Phosphorus, potassium, etc., and preceding crop. Preceding crop, there were 3 different preceding crops, but really mostly cereals, so that effect kind of fell by the wayside, and we're really just dealing with cereals, so that's not an issue. And here's probably the most important slide of this presentation, and that's the outcome of the model. And I hope you can see the titles at the top, at the back. I know I'm sitting at the back, and I'm having trouble, so I'll talk through them as best as possible. The first thing that we have, so I'll explain the bar graphs very briefly. Each yield, protein, and oil have a set of bar graphs of the 11 most important variables that the model returned. And the bars are centered, what's called centered and scaled parameters. Basically, a larger bar means in either direction. To the top means positive related with protein yield or oil, and a larger bar to the south of the line means more negatively related to yield, oil, or protein. Overall, and then we've got the parameters aligned based on the season, with essentially the first 3 are pre-seed, applied nitrogen fertilizer, soil pH, and seeding date were deemed important. Then we've got 4 parameters that were part of the vegetative phase, and that is the number of days with minimum temperatures 8 to 12, maximum temperatures 21 to 24, and then pre-flower minimum temperatures of 12 to 15. So if we interpret this, that means we're dealing with a nighttime and daytime temperature thresholds. We've got days to flower, so some genetics are in here as well, days to pod fill, and then more environmental variables for the ripening period, and that's maximum temperature and rain, and then days to maturity. Now, what I've done with the arrows here is just pointed at the 4 most important ones for each yield, protein, and oil. And you can see that none of the pre-seed ones are really that important for yield, but certainly the maximum temperatures, the number of days with maximum temperatures in 21 to 24 degree range pre-flower plays a pretty important part on yield. Days to flower are negatively related with yield, so as the number of days, as we have fewer days to flower, our yields tend to go up. And then what's very important is the temperature and max temperature and rainfall during pod filling and during ripening. So that's the yield story. Protein and oil, very interesting. My member said earlier that we know there's this negative relationship between oil and protein content, and unfortunately it shows up quite loudly here as well. And that is any of these variables, the top 4 that influenced protein positively, they influenced oil negatively. And one of the first ones is nitrogen, fertility, so end fertilization. Turned out to be quite important for increasing protein, does kind of make sense, and at the same time decreased oil. Then when we get into the temperatures and into the vegetative phase, we see that it's the nighttime temperatures of 8 to 12 are very important for increased protein content, and daytime maximums, number of days between 21 and 24 are very important for increased protein. And again, both of those are related to also drive lower oil content. And when we get into the ripening period, the most important thing was temperature, max temperature. And as we have higher and hotter, higher temperatures, hotter days, we end up with more protein, less oil, and vice versa. Interestingly, rainfall played no role in terms of deciding the oil and protein content in this study. So unfortunately, from a reading perspective, the top 4 seem maybe a little bit boring, because as you increase one, you decrease the other, and that's not necessarily a good thing. But out of the top 11 variables, we also observed a few that where we have a differential response between oil and protein, and those are probably much more interesting from a breeding perspective. In that with soil pH, as we increase pH, we tend to get lower oil content, but no change in protein. And same with some of the temperatures during flowering, and also days to pod fill, more responsive to oil content rather than protein. So I'm down to 2 minutes and 24 seconds and about 2 slides left. Another thing that's not related to the Corteva data, but it's some stuff we're doing with actually Dr. Shurtleff, who I saw walked in a few minutes ago, is looking at stand density in his experiment where we're looking at modeling yield with stand density. We also looked at that data from the protein side. And in some locations, not always, but in some locations, we see this negative relationship. As we get higher stand densities, we tend to get slightly lower protein. And I've modeled it between what we think is typical, farm density. So from 20 plants per meter squared to about 100 plants per meter squared. So while this is of no value to the Corteva data analysis, because of course, we don't see these big changes in stand densities, on farm, we know that there are big differences in canola densities, and this might play some role in explaining some of that CIGI or Canadian Grain Commission data. Last but not least, what's the take-home message here that we've learned so far is that genotype, environment, and management all play important roles in canola seed quality. Really, the whole season, the entire season is involved in contributing to seed quality, from pre-seed, what we do pre-seed, to what happens at the end of the year. Very important on the quality side are temperatures, which of course we don't have a lot of direct control over. Indirectly, we do with respect to, days to flower and those types of things. But directly, temperature plays a very important role in terms of protein and oil content, and fertility and stand densities may modify this as well. Going forward, we're going to actually include ADF into this model as well. We're just compiling the data for that and see how that fits into this big picture of canola seed quality and canola seed constituents. And I'll leave it at that with some acknowledgements that you have 27 seconds to look at. Thank you.
Thank you very much, Dr. Gulden. That was great. And I was glad to see that Saskatoon was the best place in the prairies. I think that's what you said, right? I think yeah, absolutely. Yeah. Okay, sounds good. Next up is Brittany Wood. And so she's with the Canola Council of Canada, and her topic is global and domestic feed markets, opportunities for canola meal, a topic I'm very interested in and I've had a chance to work with Brittany on, so it's going to be hard for me to cut you short on the presentation, I suspect. Brittany joined the Canola Council in 2012, manages the council's utilization program that promotes canola seed, oil, and meal in key markets of importance for the industry. In addition, she manages the canola meal research program and works towards disseminating the results of research to industry and raise the value of canola meal in the diets of all livestock and aquaculture species. She's very passionate about this topic, so I might have to come here with a big stick and pull you off afterwards, but come on up, Brittany.
Hi, everyone. Nice to see you all. It's really nice to be here, and thanks for the introduction, Rex. Yeah, I can be a little bit passionate about canola meal because it's really because I like cows, and that's the main reason. Okay, so I'm going to talk about our global and domestic feed markets, and I'm going to link this all back to kind of a supply and demand scenario. So I'm going to talk about the current market situation for canola meal because that's changing. We need to really talk about it and understand what it's going to look like. But it's also the North American oilseed meal landscape that's changing. So there's more than just canola. We need to talk about soybean meal as well. And then so that's supply, then we're going to talk about demand. So what is the world demanding in terms of protein ingredients, oilseed meals, particularly for livestock feed? I'm going to take a couple of slides just to entertain me while I talk a little bit about why canola meal is so great, specifically for dairy cows. And then I will share a little bit of the market opportunities that we see and what we're doing at the Canola Council to promote canola meal. Okay. So this is the Canadian canola meal exports. So this is what you're seeing up here. So this is about 10 years of data showing where canola meal from Canada is going. Now, everyone is probably very familiar that canola meal is going to the United States, and that's the yellow bars. And of course, the takeaway, the instant takeaway from this is, of course, just how important the United States is. The other one is China. So that's the red bar at the top there. And I do want you to also take away just how important China is currently and will be going forward for canola meal exports. Oh, sorry. That's okay. I'll get back to that point. But let's talk a little bit about the United States specifically. So as you know, canola meal is going primarily to California. You can see that there in the high bars right on the left. And this is about 4 years of data. And so canola meal exports are very well aligned with the top dairy producing states. So when we say canola meal is feeding the dairy cows in the United States, that is really true. That's really where it's going. And in California, we would say it's pretty much entirely going to feed dairy cattle. There are some interesting things though here that I want to point out. So California, you can see just how much canola meal is going to California. There's about 1.7 million cows, dairy cows in California. Then if you see Wisconsin, it's kind of in the middle there, and it looks like all the other states really. It's about 200,000 tons of canola meal that's going to Wisconsin. So Wisconsin has about 75% of the cows that California has, but it takes about 15% of the meal that California does. So this is an interesting situation of really where logistics, availability of feed ingredients, how the herds look in these two states are really quite different. And that's why we see these differences in exports. If it was a perfect world, we would see a lot of canola meal going to Wisconsin. We'd see a lot more canola meal going to some other states as well, and we would really be actively promoting into those markets. California has large herds. The farms are receiving individual feed ingredients. There's a lot of connection directly to canola meal. We have well-established rail and distribution centers in California, and there isn't soybean meal in the backyard. So moving on to Wisconsin, you have that very different situation. You have small feed mills, smaller farms. I shouldn't say small feed mills. You've got feed mills, smaller farms, and a lot of single rail cars dropping off to different feed mills around that state. And so it just looks very different. There's a lot of other feed ingredients available nearby, including soybean meal. Now, let's not forget about Canada. Canada is the third most important market for canola meal, and it's definitely not one for us to kind of disregard or forget about. It's actually very, very important. So every year we see about 500,000 tons or more of canola meal stay in Canada. And we've seen actually volumes up to 750,000 tons, which is pretty significant. That difference even from 500,000 to 750,000 tons is a big volume. Very likely what we saw in that year, 2020, I think it was, 1920, probably very high soybean meal prices. So we're seeing more canola meal used in Canada. But what this shows here is that there is room for more consistent higher volumes of canola meal to potentially stay in Canada. Okay. Now let's move a little bit to a market outlook. Okay, so we've talked about where canola meal is going, but let's just take a few minutes to talk about what the market is going to look like, because this is where things change. Okay, so Chris Vervaet had this up this morning, so I've stolen this from Chris with his permission. But what it shows here is all of the crush expansion in Canada and the United States for canola and soybean meal, for soybean, driven by the demand for biofuels. But what this results in is a significant amount of additional meal. So for canola, that means we'll have about 3+ million tons more canola meal. And what it means in the US is that we might have upwards of 12 million tons more soybean meal. So everyone knows that the soybean has a lot more meal in it, right? So if we're crushing soybeans for oil, then we're not lined up with the demand for soybean meal. So we are going to see a lot of these protein ingredients available in the market, and it is going to be impactful. Okay, let's do a little bit of a balance sheet here. This is 2021, where our exports were going. So United States, China, Vietnam, Thailand, Mexico, other, that's usually a few different places. But this is where canola meal went to. I also have Canada. And then I have canola, or Canada value added. So I just wanted to include that because that is definitely going to be increasingly important. So what do we think is going to happen in 2025 or 26, 27? So just a time frame a little farther out when we have a lot more canola meal to export or sell. The US, I think we're going to stay stable. I don't think that we're going to be in a great position to put more canola meal into the US. Maybe I'm wrong, but it's going to be tough competition. We're going to want to maintain our market. China, a lot more canola meal is going to China, that's for sure. So we need to really consider the importance of that market. Thailand and Vietnam are both situated to take more oilseed meals, and their industries are growing. So they're important. Mexico, I think, will stay stable. There's just so much competition. Other markets are going to go up. Canada, hopefully we see more canola meal staying in Canada. And value added. So that's also going to be an increasingly important market to help with all of this additional meal that we're going to have. So I didn't say this at the top here, but right now we have about 5.7 million tons of canola meal. We're looking at about somewhere around 9 million tons of canola meal that needs to find high value homes. Okay. So what does this mean on the demand side of the equation? So first you look at what is the demand forecast for meat consumption, because the animals are eating what the product that we're producing. So LMC International is kind of a commodity think tank that we work with quite a bit at the Canola Council. They have some forecasts around meat consumption and oilseed consumption. So we do know that globally meat consumption is going up 1.4% out to 2035. You can see there that's an additional 37 million tons of meat. I haven't included milk on here as well, but definitely in certain parts of the world, milk production is going up. There are certain countries that are driving a lot of that increase as well. So countries like Canada and the United States are not driving that. So it's definitely developing countries and Asian countries that we're seeing that growth. And so the world is actually projected to need 106 million metric tons more oilseed meal. So mainly we're thinking soybean meal, canola meal, rapeseed meal by 2035. Okay, so I'm gonna take just a little bit of a deviation here and talk about playing to canola meal's strengths. And this is important because when we look at what the competition is going to look like out into the future, I think it's really important that we really maintain canola meal's strengths and what those are, and that's where we're really gonna put our efforts towards. So we can feed anything. Canola meal can feed any animal, any fish really. There are some limitations, but truly it can go anywhere. But where it goes best is in the dairy diets and in certain aquaculture diets as well. So these aquaculture diets that I'm speaking of would be more omnivorous fish that have lower protein requirements, can handle more fiber. So our regular commodity canola meal can work really well for certain species. Okay, so what you see here, this is a diagram showing milk protein score. So this is something that the dairy industry looks at to better understand protein ingredients. So the milk protein score, another way to measure the value of an ingredient, takes the amino acid profile of the protein source and compares it to the amino acid composition of milk itself. So you see that canola meal is the third from the bottom there. It has the highest or the best milk protein score compared to any other vegetable protein meal. And so what that means is that this is just a great way of depicting why canola meal is so great for dairy cows. Okay, it's very well matched up, the amino acid profile, to produce high quality milk. It also is a good depiction of why it works for fish, because fish meal, you can see canola meal compared to fish meal, very similar in terms of that milk protein score. And so that is another reason why the amino acid profile of canola meal actually works quite well for fish. And Dave is going to probably elaborate on how more value-added protein products for canola are really well suited for fish. Okay, I'm sure you've all heard this either from me or from someone else. Cows-fed canola meal produce more milk. So this is hands down, undisputed information. And so I just wanted to remind you all of that, and also to say that we now have some data that's showing that canola meal actually, canola meal fed cows in early lactation, so when the animal is most susceptible, needs the most amount of resources and energy, we see even more. So if you see there along the bottom, this is various different trials comparing canola meal to other oilseed meals. And then on the axis there is how much additional milk per cow per day. And so the big bar there, number 10, this is some research we have out of Wisconsin that shows that cows fed canola meal in early lactation produce 4.5 kgs more per cow per day. So the story continues on why canola meal is so great for cows. So I'll just take a second here to talk about the sustainability angle as well around canola meal. So countries around the world, including Canada, are very much looking at methane as a potent greenhouse gas and looking at ways to reduce methane in order to reduce their GHG emissions and their footprint. And the Global Methane Pledge that I'm sure many of you have heard about is one that Canada has also subscribed to. So on the left here, this comes from our Canadian government. This is Canada's methane strategy. And so cows belch out methane. That's a fact. And you can see on kind of the left-hand side at the bottom there is the portion for the dairy cow. So dairy cows are emitting methane, and we're looking at strategies in order to reduce that methane output, feeding strategies, of which canola meal is one. So this is some data that's going to be presented in more detail on Friday. It comes from Dr. Shoki Benchar at Agriculture and Agri-Food Canada. What he did is he fed very high amounts, so increasing amounts of canola meal. 24% canola meal in the diet is a large amount. Cows produce more milk, and they emit less methane. So not only are they more efficient because they're producing more milk, they're also emitting less. Okay. So 5 minutes left here to talk about the opportunities. All right. So we know that the situation is going to be highly competitive, but we know that globally there is demand, and that demand is increasing. It's just a matter of whether or not I think the availability, the supply, is going to match up with that growing demand on the feed side. So we'll have to see. But we will be spending some time shoring up demand in California. So this is our main market for canola meal. And so we do need to make sure that we put some effort into this market so that we don't lose any of this market share to soybean meal. Right now we feed about 10%. So if you just make some rough calculations, all dairy diets in California get about 10% canola meal, let's say. We're going to be challenged by soybean meal, although the data definitely shows that if you take a canola meal based diet and you take out some canola meal and put in the soybean meal, you will lose on milk production. And just a note here on the California dairy industry that there is lots of talk regularly about just how heavily regulated that industry is, are farmers pulling out of California. But we do see that market to be pretty stable. So we do think, we will continue to be seeing that be our main market. Now moving on to China, on the right-hand side here, so again from LMC, they were able to take a look at what is going to be the demand in a particular country for canola rapeseed meal, and how much of it will come from Canada. So the green bar is total, and then the gray line underneath is the supply from Canada. So you'll see here that Canada is going to supply a huge volume of canola meal to China in the coming years. There's lots of reasons why that market in China is growing. And so there's some up there, but I'm going to actually flip to the next slide here and just highlight the growing dairy industry that we see in China. So China does have a strategy to increase the amount of dairy production as a country. So that is supporting the dairy industry in China. You may have heard rumblings of China actually looking to see if their population can reduce the amount of meat that they consume. So that is on our radar. But we do know that the dairy industry has a pretty good trajectory here for growth. Also on the right-hand side is projections for aquaculture growth. And the kind of that orangey red section on the top there is specifically to lower value whitefish. So this would be your carp and tilapia, the ones that have lower protein requirements. This is where canola meal works really well. We can put a lot of canola meal into these diets, and we see that industry growing. So that's a positive. Okay. Diversification into the Indo-Pacific region. So of course, we can't just rely on China and the United States. We need to consider other markets. There are other markets that are poised for growth. I would say Vietnam is probably the best one, maybe Thailand also. You can see here that both of these countries do import canola meal, either canola meal or rapeseed meal, so it's going to be differing quality. And Canada's not supplying it right now. So we have an opportunity to supply these markets and close that gap even between what they're importing from other countries and what Canada can supply. So specifically, Vietnam has a growing meal market. They also have a really specialized dairy industry. So it's small, but if we fed all the cows, the dairy cows in Vietnam, it's about 300,000 tons of canola meal that could go in there. So there's a market. Other countries as well that I'm not going to walk through in detail, but just so you know, we are looking at several countries in the region that we see opportunity. Okay, so I'm going to skip through this so I can get to the end here, but this is a picture of me this past August in Vietnam at TH Milk, which stands for True Happiness. And it really is one of the coolest dairy farms I've ever been on. All right, so in conclusion, I think this is a good news story. So oilseed meals will be plentiful, particularly in North America and in the global marketplace in the coming years. So competition will be strong. But the feed industry is anticipated to grow globally. So we will have a product that has a home. We have an opportunity to capitalize on growing dairy markets in China. We have a huge opportunity to tap into the dairy industry in China and other countries like Vietnam, as I've said. I also want to highlight canola meal is versatile. So it can go into any diet, like I say. We want it to go into the highest value markets, but we can feed pigs and chickens. We can really feed a good variety. And beyond that, beyond traditional uses, we have innovation that we've heard about so far and that we'll hear about coming up. And that innovation in canola protein will also be very important in opening up new markets for canola meal. Look at that, I'm pretty much on time. Okay, all done.
I'm shocked. You covered an awful lot of really good stuff really fast. That was amazing. Thank you very much, Brittany. Next up, we have Dr. David Dzisiak from Botaneco, and he's going to talk about there's canola in my salmon. And so Dave joined Botaneco in April of 2019 as CEO after enjoying a 38-year career with Dow AgroSciences and Corteva, with experiences in sales, marketing, management, and global business unit leadership. He helped shape the plant genetics and biotechnology strategy for that company. And he served on the board as the chair of the Canola Council of Canada. And he's had a long passion for canola. So I'm really looking forward to your presentation, Dave. So come on up.
Thanks, Rex. I have to travel with you more because I got 2 promotions. I'm now a doctor and a CEO. So anybody that knows me was laughing, especially Chris Anderson. But anyway, it's great to be here today and be back in the canola community and being able to talk a bit about what Botaneco's been up to here in the last few years. So first, Can you go back to? Hit the red one, thank you. Okay, we missed a slide in there. Anyway, we'll start here. So as Brittany was touching, the demand for animal feed is going to expand dramatically in the course of the next decades. And it's a great opportunity, for agriculture and especially the canola industry. And one of our focuses at Botaneco is really taking a look at the ability to put canola protein into these high-value aquaculture markets like salmon and looking at shrimp. And so here you can see in the slide they were now at the point that we're farming more fish than we get from wild catch. And that's a pretty important inflection point considering fish protein is the largest source of protein in our diets globally from both sources. And so if you're farming fish, you have to feed them, and that's a great opportunity for canola. I have to improve my PowerPoint. Brittany's turned out perfect and mine aren't. But there should be a nice picture of a canola field there. But if you look at canola in Western Canada and look at oilseed rape in Northern Europe, really it's the largest underdeveloped reservoir of high nutritious plant protein globally. And so the soy industry is well advanced, and even crops like peas and pulse crops are much further advanced in terms of taking advantage of that protein. And so, why is that? I'm missing all my pictures. So there's two really great pictures in here. But really what it talks to is the conventional processing industry. So we've got a great processing industry that's been really optimized to extract oil. And the protein has really been left over really as a byproduct. And today we sell it into probably one of the least valuable markets possible. And so I always referred to the traditional industry as kind of a tradition unhampered by progress. And I hope that Botaneco can represent some of the progress that we're looking at going forward. So this industry is not going away. We need to have it. It produces important products, especially with the demand for oil that we've seen here. So what does Botaneco do? What we're about is bringing a different way to process oil seeds. So it's really a water-based wet milling process. It runs at room temperature. There's no chemical reactions. We don't use solvent. We don't use very much in the way of heat. And we can take high oil feedstocks like canola, sunflower, safflower, and we also can take a subset of the process and start with canola meal. And through this aqueous process, we really separate. We take the seed apart, we disassemble it. And early on in the process, we separate the lipids as oil bodies, separate them from the proteins, and separate them from the carbohydrates. And our main two focus markets today are in aquaculture for canola protein concentrates targeted towards salmon and shrimp, and also in food markets for the fast-growing plant-based food industry. And the oleosomes, which will be a presentation for another day, and looking at protein products for applications into those markets. So canola's never really worked in salmon. There's been two studies here. One of them you can't see, but years ago, there was a group that did a pretty detailed look at canola meal and its fit into salmon aquaculture. And salmon are very sensitive. If they don't like the taste of the protein pellet, they actually spit it out. And so they're very sensitive to anti-nutritional factors, but it's a very high value market. That's the highest value market in aquaculture. And so what these first studies found was that you really couldn't put in canola meal at more than 10% inclusion. I'm sorry, that wasn't canola meal. Those were the early canola protein concentrates. And even these early protein concentrates, which had met the hurdle for protein concentration, couldn't get rid of the anti-nutritional factors, which limited their inclusion, which by limiting the feed intake of the salmon, and therefore they couldn't really grow very well. There was a good review paper done last fall by a group out of Germany, which took a bit of a meta view of all the previous work done in looking at canola protein into aquaculture species. And that bottom paragraph kind of states that it's really a highly promising alternative for fish meal if we could do something about the anti-nutritional factors, and that would allow for higher inclusion rates. So there was a really beautiful pie chart here so just work with me. Imagine a pie, and 70% of that pie is canola protein. So what we've done through our process is really highly concentrate the protein level. We're at 75%, and that's never been done before, and that's a really key attribute for getting a protein concentrate into this market. The other thing that we've been able to do, because we can pull out the hulls and fibers really early in the process, and because it's an aqueous-based process, for the first time, we've got the anti-nutritional factors down to well below a no effect level. And so those two elements, our attributes, are really powerful in terms of the ability for canola protein concentrate now to fit into this marketplace. So because of the process, and making a canola protein is very dependent on the process used. So just because you're making canola protein concentrate, it doesn't mean that all processes will deliver the same quality of protein. So again, we can make it highly concentrated for the first time. We can take advantage of the very balanced amino acid profile that canola brings. So we have a better amino acid profile of any plant protein used by the aquaculture industry today. We've gotten rid of the anti-nutritional factors. And by using canola, we can also take advantage of the strong sustainability and climate change position that canola offers. So there's lots of issues, say with soy protein, which is dominant because of issues that relate to deforestation and impact on indigenous peoples in the Brazilian rainforest, and which is an issue for that industry. And because of the size, scale, and scope of canola, we've got a very scalable process that takes advantage of a very large feedstock, which is a key attribute. So in looking at our results, we've done 5 major feeding trials in salmon and in shrimp with different inclusion rates, at the highest one being of 20%. And what we found that we've either maintained or improved feed and growth efficiency. In young salmon, we found they really accelerated their growth. There seemed to be differential benefit there. In looking at shrimp, we improved the feed conversion and growth almost in a very linear fashion. So as the dose of allophane went up, which is the name of our protein concentrate, actually growth and feed conversion improved. We've seen very surprising results in improved animal health. We've been able to drop mortality significantly, both in salmon and in shrimp. And we've got some ideas as to why, but this is a very unique and important benefit that we believe in making canola protein more of a functional ingredient. I'm not sure what this slide was. Let's see, and that is the end of the presentation, which should not have been. No, we've got some more here popping up. In shrimp, we were able to completely replace fish meal in that diet. And so we had, again, excellent growth and performance. This is a very large, fast-growing market. It's a 5 million ton feed market. And at the highest inclusion rates, we were able to bring about a fish meal-free diet, which is a strategic goal for some of the largest shrimp feed companies in Asia Pacific. So I guess we'll wrap up now with this slide. So our process yields some very unique attributes for this canola protein concentrate. Again, very high in protein content, very balanced in its amino acid profile. It's got the best amino acid profile of any protein ingredient, vegetable protein ingredient going into aquaculture. It's got great digestibility, which hasn't been seen before. Because of the crop base we're using, it brings scale, which is really important for the aquaculture industry. It's a very large global market. And out of Canada, we've had the 4th largest salmon farming industry here. But out of here, we can also access larger markets like Chile and going into Southeast Asia and the rapidly expanding shrimp market through Central America. Because of the feedstock, we've got really consistent quality. And because of the scale we can bring, we can make it price competitive. So we can get into the ration at a price that would allow rapid adoption at a very high level. So other alternative proteins like insect meal and single cell fermented proteins are very good, but they need scale to bring down their cost to a point where they can actually buy them. And we can avoid that with the process and the feedstock that we use. And it's not soy. We avoid all these social sustainability issues that crop faces. And if you're in the salmon industry, salmon is perceived by consumers as being very healthy. And they're very proud and very strict of the supply chain that feeds it. So you need to be aligned with those values and attributes around your sustainability and climate change position. And That might be the last one. Anyway, we went to 0 anyway. So this might have been a test. Hopefully I passed on how to do PowerPoint. But really appreciate the opportunity to come back and speak with you here this afternoon. Thank you.
You can take a seat, Mike. I was going to give you a PhD, but now we got to hold off till you get some more slides. I'll get my speakers to come on up, and we're going to have a panel discussion. And I'm going to introduce one more panelist as well. So that's Nienke Lindeboom from AGT Foods. And so Nienke is a principal investigator at AGT Foods and Ingredients, Inc., where she's involved in AGT's core business of post-processing ingredients, as well as its new endeavors in the canola space. So over the last 20 years, she has developed a strong expertise in research and development, process design, scale-up, commercialization of food and feed ingredients, nutraceuticals, biofuels, industrial products from a wide range of bio-based materials. And so what I'd like to do for this panel discussion is I want it to be an open discussion. I think we've got a really exciting time in history right now. I think this is an inflection point where we're going to have all this extra meal coming on the market very, very quickly. We've got a lot of excitement around plant proteins for human use. We've got lots of opportunities in the aquaculture side. So I think we've got lots of things we can discuss here. We've got the right people on the panel. And so this is your opportunity to ask them some questions. And if you don't ask them questions, I'm going to come up with some hard questions. I'm in final exam mode right now and thinking about exam questions for my students. So it might be best if you guys come up with the questions. So let's open up the panel for discussion. And I think there's a microphone. There it is. Yeah, right back there. Right in the middle. I can't see who it is. The lights are in my eyes. While we're doing that, I should have introduced myself. I'm Rex Newkirk, and I'm an associate professor and strategic research chair at the University of Saskatchewan, the Department of Animal and Poultry Science. Yes.
Yeah, a question for Dave Dzisiak. Dave, you were mentioning that in your process there, you're in essence concentrating the protein for the fish and getting rid of the anti-nutritional factors and those other types of things. So what happens to those leftover components? Do they end up being just discarded, or is there potential use for them? You know, some other use for them, or are they just, do they make good crack filler for pavement or something like that?
Yeah, I haven't met anybody wanting to have like a glucosinolate storage facility yet, but they do get a lot of the anti-nutritional factors reside in the hull. I'm looking at Keith for approval on that answer. And so by getting rid of the hulls, we get rid of a lot of it right off the bat. And then a lot of it does go into the water. We're able to reprocess 2/3 of the water that we use. And so they end up in those two streams, but they stay out of the protein concentrate, which is where, that really is a big part of enabling the value and the nutritional profile.
Excellent. Would anybody else like to address the topic of where the others go? Okay, more questions from the audience. Yeah, Keith. Oh. Who's got them? It's coming.
Whatever happened
I'll repeat the.
Got it.
right there, a reduction in fiber and undesirable things. Oh, you got a higher oil content and a higher protein content. And Earhart and I felt that we would have a yellow canola by now, but I'm not sure it's going to be that much harder with hybrids. But it's still high potential. And talking about pollen, there it is right there in front of you.
So the question is, what happened to yellow seed coat? Yeah. Yeah, so what happened to yellow seed varieties? Because I'm no longer in the industry, I can give you an answer now. I think one of the main drivers is that there's been such a focus on yield. There was no reward for growers around protein quality. And so without that kind of a value signal, it just never really there was no attention and really paid to it. And so that, to me, that's probably one of the largest drivers. There was no market signal to say we needed to have this. He agrees.
Yeah, we have research on that Gencia product, feeding pigs and chickens, I think, and the results are good. So of course it's going to be a higher value meal product, but yeah, I think the others know what the challenges were on the agronomy side.
And certainly, if as a feedstock we're looking to add value, if we had the material to process, I think that would be an opportunity for that concentration business. So yeah, I think I seen a hand way at the back. Did I see one?
Nim has some questions from
Oh, there it is.
online
There. Okay,
as well.
yeah, thank you. Yeah, got some online questions.
We have some online questions. Two questions to Rob. One is looking at the PLS regression coefficients bar graph. I am surprised that applied N fertilizer is negatively correlated with oil content. As the oil is currently the highest value product, would you recommend less N fertilizer?
Yes. No, that's a really good question. Again, we'll have to tease through that data a bit more. We're dealing with research plots here, and so fertilization of research plots is not necessarily always doesn't necessarily always line up with fertilization of farmer fields. But it looks like that relationship is going in that direction. And maybe there is something to apply it in. The nitrogen picture on that study is a little bit more complicated than that, in part because we, at this point in the model, do not have the residual soil nitrogen levels included. We didn't have that data. I think we're trying to gather it. And then maybe that relationship changes a bit. At this point, it's referring only to applied N. So it could turn out that that applied N is much more easily taken up by the plant and turned into protein, more protein / less oil. Or with the background level, some of that will go away. I don't know the answer to that, so I'll modify my yes to maybe.
Next question to Rob.
And thank
Could
you.
you please provide more details as to why you think precipitation was not found an important factor for yield or protein? In other research talks, it was usually found one of the most driving factors. So I was interested to learn more details in the case of your research. Thanks.
Oh, another great question. That's going to take a lot more looking at the data. No, precipitation certainly showed up on the yield side, if you remember. So late season precipitation during pod filling and ripening certainly increased our yield, but it did not have an effect on the protein / oil proportion or oil content. Again, it's going to take a little bit more sifting through. I was expecting to see precipitation come out as a much more important factor during the vegetative phase, but it did not. And I'm not quite sure why that is. We haven't completely sifted through that data set yet and still have 3 months to do that, to get a better understanding of how some of these factors that the model pulled out as important factors, how they relate, because some of them do relate. For example, if we go back to the yield information, we did see that maximum temperatures was flagged as an important factor for yield, but then at the same time we also saw that the days to flowering was negatively related to yield, because typically we would think the later that the canola is or high yields during a pod fill have or during the reproductive phase have a negative effect on yield. But in this case, I think that is somewhat related to the fact that if the plant flowers earlier, then the maximum daily temperatures play a more important role. And if we push that flowering later into the season, then actually the maximum daily temperatures become more of a detriment. Again, we still need to sift through that, but those are very good questions. And I hope that was the last question from.
Is any more questions out there? I'm looking for hands. Yeah, you want to bring the microphone up for? Can you hand the microphone to Keith? Sure. Thank you.
Yeah, this is for Rob. Many years ago, we did an environmental look at the canola or the Canadian Grain Commission data just on oil and protein. And it was very obvious there that as you go north, you got more oil and less protein, and the reverse as you went south. And that was a really very clear correlation between those. And I like sorting it out, but you're using data from the research plots, or are you using farmer samples?
For the last analysis, it was research plots because we just don't have that information from farmer samples. We tried our best with that, but it's very difficult. It'd be nice to have that information from those farmer samples,
Yeah.
and but we don't, unfortunately. And I agree with you. I mean, when I showed that one slide, you can see certainly there's this gradient or relationship there. What I find interesting from this, and that's getting in the weeds. I guess as a weed scientist, I should, is that we're finding these periods of during the development of the plant that are very important, and nailing that down a little bit better, which then hopefully will inform even going forward the breeding effort if we're looking for that. Because if we know what parts of the year specifically to avoid, or where there's room to move there if we know that information.
Yeah, but you're using research plots, and they're pretty well weed-free.
Oh, very true. And a lot of these other things that you would see on farm, which is I threw that density graph out at the end. There are things that happen on farm that don't happen in research plots that also affect protein and oil content. And I mean, we're doing the best with the data we have, but absolutely, there are things that we will not account for. Hence, we still have a lot of unexplained data in that data set.
Excellent. I'm going to take Rob off the hot seat for a minute and put Nienke in it because she hasn't had a chance to speak yet. So AGT is really well known for its pulse work and pulse proteins, and they're certainly a global leader in that front. And so I'm just wondering, why canola? Why is canola protein interesting to that company and the work you're doing?
Well, for several reasons.
Up to the
So AGT, as you all know, is in the pulse business. We do commodity trading. We do a lot of processing of pulses, and that has really come up as part of the business in the last 10 or 15 years. And recently, as you might have heard, there was an announcement between AGT Foods and a federated co-op, as AGT Foods being one of the grain companies that was discussed earlier for the renewable fuel production complex that Federated Co-op is developing together with AGT Foods. So besides a commodity trader, we also have a large distribution work within the different provinces, and a large interest in feeding the world through different means, and pulses is one of them, but it doesn't have to be the only one.
Excellent. I think right now it says, it's an exciting time to be in the canola world because the world does need that protein, and there's lots of opportunities for it. So I thought that was a great example of leaders coming into that industry. More questions from the audience? If I don't see one, I'm going to ask another question. I'm going to pose that same question to all of you guys. Why are you so passionate about canola? What's canola got to offer? Why should the consumer be so interested in canola as you guys are? Who wants to take that one on?
I guess I can start. I mean, I think, the amino acid profile of canola meal makes it just so universally a good fit for every end user, animal, human. I think that's really what it comes down to. But then it's also the environmental story that Dave touched on, the environmental story on the dairy side that we're seeing come out. There just continues to be more and more good news, I think, about canola meal, canola value added ingredients. So it's not enough good things to say.
Perfect.
For me, I think, well, I came from the canola industry, so I came into the job a little bit biased. I'm obviously really passionate about plant-based foods, and I think that canola is an ingredient that the industry needs. Like Dave said in his presentation, a lot of companies are looking at anything that's not soy. Canola pairs perfectly with pea, also pairs well with fava. It's got so much opportunity. It has so much to offer. And as Brittany said, the sustainability story, the supply story, all of those things are in its credit and will make it a success.
Yeah, maybe to add a little bit more to it, well, Lisa touched on it. Like soy and wheat protein represent over about 90% of all the protein that goes into the plant-based food industry. And that's an industry that's just beginning to grow. And so you've got a young cohort of consumers around Generation Z that are eating differently. And so I might be very committed to ribeye steaks. My son isn't. And so that generation, if they can avoid 100 million animals in confinement and slaughter, if they can avoid or help ways to mitigate climate change and eat healthily, then they're all for it. And that's going to take a lot more plant protein. And canola is a great material, and it's just been underdeveloped. And so for us, we see it as a great place to invest. And it's a market that's growing fast. It's underserved. Aquaculture is the same way. And so I think the time is now to take advantage of that part of the seed and really, let it reach its potential.
Excellent.
All right, put me on the spot. Can I do one word? Research funding? No.
That's a good word.
Excellent. No, as a scientist, research funding obviously matters, but as a scientist, and I'll take a research angle to this. I find canola a very interesting plant, and I've worked on it for a long time. I did my PhD on volunteer canola, and I find it interesting in the sense that it's a crop that is partially domesticated. We can argue that all day long of how domesticated, but it's a fantastic crop that has a lot of interesting characteristics still that we don't fully understand, and it's also not entirely it's not best adapted to the Western Canadian environment. It evolved elsewhere, and so we deal with canola at the fringes of work and grow, and that makes it very interesting from a scientific perspective to study and better understand. And then we'll go back to research funding.
I'm going to ask one more question then. Was there a question down there? Yep. Sure, go for it.
We have some questions for David. How much variability do you see in the amino acid profile among different canola varieties?
Good question, because we only work with one variety, because we don't want to have the variability in what we do. But it might be a better answer for you in terms of the amino acid profile and the variability.
Oh, that's a great question. Great question. I don't know the answer, but I know somebody over there is sitting there that's studying that. That's one thing we haven't looked at in our model. Again, even with what we're doing, we're just looking at total N or total protein. I suspect it gets much more interesting if we actually start looking at protein constituents versus be it napin, cruciferin, and then on top of that, the whole amino acid breakdown. Lots of questions to be answered, but I am not an expert on that, unfortunately.
I can maybe answer that one a little bit, if that's okay. A student of mine, CS, she's looking at making protein concentrates from canola, and she looked at different varieties, and Sally was the one that got her a bunch of samples wherever you're out there, Sally, and looked at location and variety, and there wasn't so much of an impact of variety, but there was location. And so as far as functionality, as far as PD-Cas and stuff, for whatever reason, sort of the central central region gave us the highest overall balance, and so it's more environmental, I think, than genetic in that case.
Rex, one more.
Yeah, one more.
We have more questions.
I think there's a question back there. Clint's got one. Sure.
Yep, if that's okay.
Great, thank you. Delaney Ross-Burtnack with the Manitoba Canola Growers. We're doing some work. We share a patent with a couple of inventors to work on canola milk and tofu. And we met with a company out of Poland this past week. And they made me look up circular economy because I've seen the words a lot, didn't really understand what it was. But in defining it, they were very focused on what happens to the meal after we extract protein to play in this kind of tofu space. So is that I feel like there's opportunity there with this company out of Poland, very focused on being a part of the circular economy. Has that become part of our vernacular in Canada, in meal being an opportunity to kind of close the loop related to the circular economy for canola, and making sure that all off products have a use is how I took the definition to be?
I can talk a little bit about that. I can't talk too much about what AGT is doing, but it is always in the back of our mind because we need to look at the full picture. We're looking at setting up a full canola biorefinery process with Federated Co-op. And part of that is using every single side stream. Because if we don't use it, we need to get rid of it. If we can't put a value on it, it won't make sense for the whole economics of the whole project. So we look at every single piece. We have protein streams, we have oil streams, we have fiber streams, everything is coming up, and each one of them we're exploring how to add value to those. And that could be in food, it could be in feed, it could be in industrial applications, whatever. But we need to find a spot for it. And that you've seen, we've seen the same at AGT in the pulse industry. We do a lot of pulse protein production. As you might know, or there's a lot of starches there. We need to find a place for these starches. So we're very familiar with doing this kind of work. We have pulse fibers we need to deal with the same way as we need to deal with canola fibers. So it's complete utilization of the crop in different directions, not just food.
Good point. And I think it's about driving the maximum value and utility from those products as well. So sometimes through fractionation or by diverting them to certain species or whatever, we can get more value out of that and create a better value package.
Yeah, and an interesting point on that, and we've seen it in the pulse industry, is what you initially start your business on and where you see you create the value, which we've done in starches and pulse protein in the pet food industry. Slowly on over the years, once your volumes increases and stuff, your business model completely changes. And right now, the majority of our proteins going into the food industry, whereas 15 years ago, the food industry wasn't ready for these kind of more crude ingredients. So we can see that in the soybean industry has gone through something like that, dairy industry has, canola industry will eventually too.
I have one last question before we close off. And that is, we're really poised for an interesting time. People have been working on canola proteins for a long time, but I see some real significant movement at this moment. And we have a whole audience here that are committed to canola and excited about it like we are. But at what point do we start communicating more of this to the public and letting them know more of the benefits of the canola protein? Or have we done that? Or what, strategically, what do we have to think about on that side? I don't know, who would like to speak to that?
I can give AGT's 2 cents. So we will communicate once we're ready, and I think we'll be ready sooner rather than later. We'll have a whole lot of canola meal to deal with, and we're very strongly working on a plan what to do with it, but we can't discuss it broadly right now.
Right.
But in the next year or so, probably everybody will know what AGT is going to do with canola protein.
I'm looking forward to the day when I also can talk about it from the utilization standpoint and what I work on at the Canola Council. So whenever you're ready, I'm ready. So.
Well, I'm thinking too, just the good news story of canola for people as well, right? So,
well, I think that's where what PIC is doing is really invaluable, because there's been little elements of things around the industry, and they're helping coalesce an ecosystem around it. And so with companies like Merit, like us, like AGT, like DSM, it's non-traditional players that are bringing this innovation. It typically happens to the public. And so I think we've got a great opportunity now for canola to be seen in different parts of our food systems, whether it be aquaculture or whether it be in direct end use plant-based milks or plant-based meats. I think that day is coming soon, and it'll be a great addition into the canola story.
Awesome, thank you. Well, I thank you very much to our panel. Really valuable information. Good luck. I see great things coming up. Just a couple of things that thank you to our speakers who, in lieu of gifts to you, I've got a card for you, but in lieu of gifts, contributions were made to the Keith Downey Undergraduate Scholarship at the University of Saskatchewan. So students will benefit greatly from the work you have done. Thank you for taking your time out of your busy schedules for doing this. If you guys have more questions, please corner them. We're going to have a break now, and you can gather the speakers up and get as much information from you as you can. So we'll meet back here at 2:45 for the crop updates and reports. So thank you very much.